Hello everyone. It's an honor for me to present our research at the INMIC 2024. That's a 26th International Multi-Topic Conference, which is organized by Salim Habib University, Karachi, Pakistan. The title of our work is Enhancing the Brand Tumor Classification using CNN and Impact of Data Augmentation on Model Generalization and Performance in Federated Learning Environment. So my name is Ziaur Rahman, and I'm the lead author of this research. I conducted this work in collaboration with Professor Dr. Syed Nasir Mahmood Shah and Mr. Uzair Hassan from Institute of Space Technology, Islamabad, and Dr. Saiful Islam from WMG, University of Warwick, UK. So in this presentation, I will cover six key sections from introduction, related work up to conclusion. So let's start with the introduction. So federated learning is a powerful machine learning approach that protects data privacy by allowing the multiple devices to train model without sharing raw data. So in this research, we present an empirical evaluation of convolutional neural network for brain tumor classification in a federated learning environment and comparing the model performance with and without data augmentation. So the finding highlights how crucial data augmentation is to enhancing the CNN model scalability and performance in federated learning. So especially in medical imaging context where data heterogeneity is critical for accurate diagnosis and generalization across diverse datasets. So let's move toward the related work. So this literature review basically explores the key research in two areas, federated learning and data augmentation. So federated learning studies from 2020 to 2023 focus on challenges, privacy, and applications in healthcare, and emphasizing the medical image analysis. And lastly, the data augmentation studies from 2019 to 2023 demonstrates its ability to enhance model performance and generalization, especially in medical imaging tasks, including COVID-19, screening, and vertical federated learning. So together, these studies provide a solid foundation for optimizing the federated learning systems. So let's discuss about the research methodology. So this diagram basically illustrates the federated learning process where multiple clients, for example, devices or data centers or edge devices, collaboratively train a global model without sharing their raw data. So the clients that are shown on the right side are locally train the model on their own data, which is the step one of this process, and sends the updated model parameter to a central server, which is shown on the left side, where the global model is aggregated. So this process preserves the data privacy while allowing the distributed learning, as only model updates are changed or exchanged between the clients and the server. So here is the experimental setups. So this is the CNN architecture, or this model is basically a convolutional neural network model with a total 8 layers, and including 3 convolution layer, 2 max pooling layers, 1 flattened layers, and 2 dense layers. And it has almost 4 million trainable parameters. So here is the brain tumor MRI dataset, which is used in our experimentation, and it is freely available on Kaggle.com. So this is the experimental setup, or details of hardware and software, and we utilize total 5 machines. One is utilized as a server, and 4 of them are utilized as a compute node or clients. Let's discuss about the results. So our result is basically divided into two experiments. Experiment number one is basically federated learning implementation without data augmentation techniques, and experiment number two is federated learning with data augmentation technique. And both are conducted on the brain tumor MRI datasets. So this table basically summarizes the results of experiment number one, which involves classification of a brain tumor MRI scan using a federated learning approach without data augmentation. So the experiment was conducted on a dataset containing a total of 900 images, with 720 images used for training and 180 images used for validation. So, and experiment number two is basically which involves the federated learning with data augmentation on a brain tumor MRI datasets. And the experiments assess how the performance matrices change as the sample size increases. So the analysis is divided into a three section based on number of original and the augmented samples. As shown in the figure, the sample size increases across three sections. The overall performance of all clients improves significantly, which indicating the effectiveness of using larger data sets with the data augmentation in federated learning. Notably, the client 4 consistently shows the best balance between high test accuracy and shorter training times. So let's conclude our research. So this study basically evaluated the impact of data augmentation within a federated learning framework for brain tumor MRI classification, and the results reveals that the data augmentation significantly enhances model performance with improvement in test accuracy, precision recall, and F1 scores. And the data augmentation or the augmented model achieved accuracy above 95%. And so the future research could explore advanced augmentation techniques and their integration with other methods to further enhance varied learning models. Here are the references which are utilized in our research and this making of this presentation. And thank you so much for listening me.